All right, everybody. Thank you for joining this webcast. And we're going to be talking about home labs today. Actually, it's pretty much my favorite topic. If you look over to my right, I don't know, your left, whatever. I don't know how this video is converted over. You can see I have a server rack next to me where I have all kinds of home lab stuff. Some of the stuff we're going to be talking about today. So I guess let's get started and get rolling. So, quick WhoAMI, full-time pen tester at BHIS. I've been doing this for a while. I have done lots of pen testing, coming up on 10 years now, pretty much just doing consulting and pen testing. So I love to automate things. We'll talk about a little bit of that in here, and I also have a class. We'll do my shameless plug as well. I am a Army veteran, and I'm kind of a home lab addict. I really do like playing around with different hardware, playing around with different equipment. I like to simulate different kinds of environments that I'll see in the real world or just something that I think is cool, right? And we're going to kind of roll into that. This talk today, or this kind of webcast, is going to be a little hardware heavy, I guess you could say, right? It is something that really, really intrigues me, but we're also going to kind of move into also some of the software, like what you can do with it, right? So what, getting it running is really fun. Doing something with it can be also really fun as well. So here are my quick warning slides, okay? This is a minefield. And what I mean by that is we're going to be talking about different stuff. And there's like a ton of opinions, especially on what's better, whether you need this and all this other ways. And somebody's going to say, I do it this way and this is the best way. That's great. So a lot of the stuff that I'm going to be talking about, just kind of my way, you guys can take it with a grain of salt, right? Lots of opinions, and that's great. I really do like it. And I'm pretty much open to hearing, hey, I heard you talk about this, but have you checked out this? And if I might not have seen it. So awesome. I'll check it out. There's plenty of options and choices. I'm not going to go through every choice today. So things can get really expensive. That goes into my next thing, which is price in mind. Okay. So I'm not going to be talking a lot about very specific enterprise gear. Enterprise gear can get super expensive. Okay. And just really kind of out of the realm of home lab, right? Now, there are a lot of people who do get wild and have tons of enterprise gear in their home lab, and I have done some of this stuff, okay? But when we get into talking about firewalls and other stuff like that, there's some vendors that want $1 bazillion for a blinky box. I'm going to avoid kind of talking about that, and I'm going to focus more on, just the individual and mainly kind of what they could, get the most value out of, okay? Lots of products. I'm not involved with any of them. I'm not selling or shilling any products. These are just ones that I've used. Pretty much everything that I've talked about, I've either used or played with in the past, or I currently am using it right now. Again, we're not going to talk about every option. Okay. So, I'm going to talk about some CPUs. I'm not going to talk about all the CPUs or this option, so just be ready. All right. So why build a home lab in the first place? Right. So learning new software and concepts. Okay. So just having a laptop connected to the internet, that's great. But, a lot of our customers in IT, they have a lot of other stuff. Some of that stuff's geared toward the enterprise, and having that gear here or being able to play around with it or to test it out is something that's really beneficial to actually learning how it works, especially in security. I have a huge belief in that you should know how it just works before you think about how to secure it, right? A lot of times misconfigurations are the number one vulnerability, so think about it. All right, so we also maybe want to test an isolated environment. Building a home lab helps us do that, right? We can make these different isolated environments. If you do it correctly, you can make as many as you want, really. We can also use this to troubleshoot problems that we might be having, right? Maybe it's just a problem with our own stuff. Maybe it's a problem that we're experiencing in our own environment or another environment. And this could be even outside of security, right? I deal with all kinds of IT problems unrelated to security just to try to do my test all the time. It just happened. This is another great way to test out patching too, right? So seeing if something actually breaks something or unattended effects or testing out proof of concept code. You can also practice your attacks, all right? I mean, this is literally what the OSCP became so popular for, right? And that's from the red team perspective, is they gave you the lab, you didn't have to set it up. That's what you were paying for, the whole thing, right? I mean, they gave you a manual, I didn't think it was that great, but it doesn't matter. That's what you were paying for, was that lab. We can also emulate production, okay? So I'll be on assessments and they'll have some product that I don't have. I'll go set it up as fast as I can. And I'm not talking about a blinky box, mostly software. And then I'll configure it and see if what I think would be a great attack does work. We can also test our malware, right? So making payloads and other kinds of things like that. We can test to see how security products respond. You could set up labs that have these products in there and see, pretty much how the whole process would work and whether you're actually getting detected, whether you're actually being sneaky. And the inverse works as well. So you can see if the product is doing hopefully what you think it's doing. All right. So when you start getting into Homelab, we do need to start thinking about some goals. So like, what do you want to solve? All right. So what is the goal of this Homelab? Okay. Also, what do you want to learn, right? I mean, these are questions you should ask yourself when you start getting into this. Just kind of, and they could start here and they'll grow to something that is, way more, expounded. How much do you want to spend? Your wallet will hurt at Homelab depending on where you want to go, right? So answering that question is something that you should definitely keep front of mind. And then how much you're going to use of this, right? So go really big, and you're not really using that much, it's not going to be, maybe it's not worth all of that money. So just questions to think about. Okay, let's get into some Homelab parts. I'm going to kind of break this down into 3 segments. The first one is network. All right, so this is where we're going to talk about just networking items. So the basics, right? A switch, a firewall, and some Wi-Fi products, right? That's kind of like the basics of your networking at home, right? The next thing we want to talk about is we're going to talk about storage. And I'm going to talk about just some simple stuff like RAID, different kinds of storage types that are out there. And we're going to talk about NASs as well. Show you just a couple different options in there. And then last, we'll move into compute, right? This is where we're going to actually be running whatever we want to run, whether it be bare metal, virtual machines, so on and so forth. And we're going to talk about the different components of our compute and different form factors, right? Different sizes that we could get of these compute. So starting with the network, obviously we need internet, okay? And we're going to need a firewall or router, and we're going to need a switch, right? So those are pretty much the basics. A lot of people just have one device that does all of those things, okay? And we're going to talk about a couple other ones that kind of segment that out. And then also Wi-Fi. Everyone's got Wi-Fi at home. And again, a lot of people have one device that kind of does all of this. When you get into Homelab, you start getting more devices that can kind of segment this all out. All right, so first, internet, avoid internet providers, routers. This is just kind of like, as soon as you start going down the Homelab route, sometimes you have to use their modems. I know a lot of people don't have a choice about what internet they're going to get. So, but go fiber if you can. Again, like I said, a lot of people in the United States, or depending on where you're from, might not have very many choices or only have one choice, and it might not be that great. So, if you do use the internet provided router or modem, right? If you're using something like cable, putting that device into a bridge mode would be advantageous depending on the firewall deployment that you're kind of rolling out. All right, so let's talk about firewalls. So some of the features that you might want to look in like a Homelab firewall, right? So this is your perimeter. Packet inspection. It'd be nice if your firewall has IDS or some kind of IPS that you could enable, right? You want a firewall that supports VLANs. Setting up VLANs in a Homelab is very advantageous. It allows you to segment your network and have isolated networks. DNS. So having a firewall, obviously, that has DNS, most do, but you could also have a firewall that has a DNS black holing, like something like AdGuard and other things like that, which we'll talk about. IP filtering, right? So obviously being able to block ports is kind of the general goal of your firewall, but having some IP filtering, maybe some stateful IP filtering. Easy management is also pretty useful. Having something that's super complex and, depending on the product, especially a lot of the commercial stuff can get more complex. And some of the products I'm going to talk about now, actually, the complexity can increase a lot. VPN, having a firewall that has some kind of VPN technology. We'll talk just about a couple of them. I'm a big fan of WireGuard, but there's other ones. All right, so one of the first firewall options is the Firewall. If you haven't played with this, it's a very cool device. And some of the benefits is that it has a pretty simple configuration. They have pre-made hardware, kind of different sizes based on how fast your internet and kind of how much traffic that you want to kind of inspect. Okay. It obviously includes some segmentation for you to implement inside of this, and deep packet inspection, and a VPN, right? So this is one good choice. If you're actually following along live with the slides, you'll see the link for the Firewall. You can go in there and go to the next one. I saw one question in Discord. I will answer it. This one is any recommended bandwidth for incoming internet connection? Anything that's high speed. I know that seems like I'm going to use air quotes for high speed, but 25. I don't know. As fast as you can go, I guess, as fast as your budget can afford, especially for Homelab is going to be useful, right? But once you get into the real high tier, so 500 and above, it's not really going to matter too much. All right. So the Firewall was one of the Firewall options. Another one that I really like is pfSense or OpenSense. They are very similar projects. Okay. And pfSense actually got kind of bought by Netgate. So they do make some commercial hardware commercial hardware. Yeah. So, but pfSense and OpenSense are in general open and free, open source and free. OpenSense is a little bit more on the open source side, but you can set up both a pfSense or OpenSense system for free. There's really no licensing requirements. You can also, in addition, buy products from Netgate, which are kind of already pre-configured in devices. So from the pfSense side, you can buy some pre-made hardware. I believe on the OpenSense side, they have some pre-made hardware. Or you can build your own, okay? That's one of the things. I've ran a pfSense box for years, and you can just build it on any kind of smaller end device that has a couple Ethernet ports. You need two, right? You need your internet and your network, your LAN side. Both pfSense and OpenSense are actually FreeBSD based, and that mostly has to do with packet routing speed. They also support some plugins to do a bunch of extra features. Both pfSense and OpenSense are very full-featured platforms, and they pretty much include most of what you would want to do inside of a firewall, including some of the IPS and more advanced stuff that you might want to implement. They also include VPN, WireGuard, OpenVPN, L2TP, which I'm not sure who's using that too much anymore, but kind of all the VPN protocols are in there. All right, here is another great firewall option, and this is the Unify UDM. And I actually am running a UDM Pro right now, but it is technically kind of a closed source. It's part of the Unify ecosystem. So if you already have a bunch of Unify gear, it's a great choice. If you have no Unify gear, then it might not be the best. But the benefit of Unify in general from the, I'm going to call them a prosumer, right, is they're very inexpensive. I think the UDM Pro is like $300 or something, and it includes kind of everything you need. They have large hardware support, so they actually have a bunch of switches and all this stuff. They kind of all work together, right? Not to shill out just one brand. It's good, it's inexpensive, so it's popular. But it isn't as full-featured, honestly, as something like pfSense. So it depends on where you want to go. It does have an amazing web management system, which is kind of its selling point. And simplicity. Simplicity also takes away from some of the features. And like I said, not as feature-rich. Another company I do want to talk about, a product, MikroTik. I've seen already a lot of people, talking about them. They make a ton of different products. Again, their price point is amazing. It is closed source. They make something called the Router OS. It pretty much runs on every computing architecture they could think of, ARM, x86, whatever. And it's very powerful. There's tons of configuration options. I think the only downside of MikroTik, in my personal opinion, I've set up a couple, is that it has so many options. It can be difficult to kind of wade your way through if you're not familiar with what these kind of technologies are, right? It does have a large hardware support. So they have a bunch of different types of routers and switches, switch only, router switches, combinations. They also have Wi-Fi gear as well. Like I said, they're extremely affordable and they have a large feature set. So there's kind of a lot you could do with one simple device. They can be complex to set up. Like I said, where something in the Unify line doesn't have as many features, honestly, but it is just easier to set up. All right, so Corey actually helped me make this like little diagram over firewalls here. And if you can see, this is kind of like the expense going up and, expense going down here, and you're up and down, and then features and easy to use going left and right, hard to use and more features, right? So you have MikroTik and pfSense DIY, your Best Buy products, which would be like your kind of all-in-ones, right? They're kind of inexpensive, but they kind of have less features. Especially for doing home lab stuff. Some of those products do go very high into the features, but it just depends. And then, up here in the top right, we also have, our Cisco's and our checkpoints, Palo Altos and stuff. They start to include a lot of enterprise features that you're probably not even going to care about. But the price just goes nuts, right? And licensing and all kinds of other stuff, right? So anyways. Let's talk about switches real quick. So something to consider when you are buying a switch, whatever brand it is, outside of firewalls, is VLANs. You want a switch that's VLAN aware. You also want something that you can manage. A lot of switches nowadays have a web interface. Something like the Unify platform allows you to actually manage the switch from a single pane of glass, buzzword alert, but just something to manage it, right? Port speed is also pretty useful, right? I'd stay away from anything in the 100 meg. Gig is the minimum nowadays, and 2.5 is actually becoming more of a standard, and then 10 gig as well. The size of that switch is also important, whether you're going rack mount like something over there, or you're going to have it on your desk or whatever, right? So consider that. A lot of the switches nowadays pretty small, compact. So another thing to consider when you looking at switches is PoE, whether it has or does not have PoE, and whether you need that, right? So some access points, for example, use PoE, and some others don't, and whether you're going to be using that or not, right? So how many PoE ports it has and what the budget is. So here's some quick switching options. So again, like I said, Unify. TP-Link also has this Amada, which is very similar to Unify. It's from the but from TP-Link, having that central management. I actually have not got a chance to set this up, but I've seen a lot of other people Homelab using it. Netgear makes some less complex, but still has some of the baseline features like VLANs and other stuff. Microtech also makes some switches that you can hook into. And then let's talk about Wi-Fi. So one other thing to consider when you're deploying your Homelab is you're probably going to be using your Wi-Fi. Maybe you're just using it for your internet, but one thing to consider is the speed. So Wi-Fi 6 is currently the latest standard, or Wi-Fi 6E. The consortium kind of changed the standard. They don't, call it 802.11a, b, AC, so on and so forth. It's called Wi-Fi 5, Wi-Fi 6. Anyways, Wi-Fi 6 is the current standard, so that's 5, 2.4, and you should be able to get about 500 meg. Also, when you're thinking about Wi-Fi, think about scale. Okay, so you just need one access point. You got a really small house. That's great, right? But maybe you got a bigger house, or maybe you want to deploy more than one access point. So consider that when you're looking at these. Management. So how are you going to manage that? If you do deploy 6 access points, do you have to log into each one to change one setting or change one SSID? Just something to think about. A lot of these products, like, again, I'm just saying Unify, and also I believe the TP-Link and other ones have started to move to more of a central management for managing lots of access points. Okay. Another thing to consider when you're looking at Wi-Fi is whether you're just getting an AP, an access point, or you're getting like an access point and router, right? So this is something like a Netgear that has Wi-Fi built into it. That is technically kind of an access point and a router. Technically, really, it's really a NAT device because it actually doesn't run particularly any routing protocols, but it does route traffic. So looking at Wi-Fi hardware, I've got a couple different things in here, but Unify, again, makes some pretty decent Wi-Fi gear. TP-Link, Netgear, like I said, Microtech also makes Wi-Fi gear. There's some other ones out there like Ruckus and other things like that. Again, the price of poker starts to go up once you start dabbling into more of the enterprise gear. So just things to consider. All right, let's talk about storage. Okay. So there is a couple different storage platforms out there, right? So we're moving on from networking. We're going to talk about storage. So we have 3.5-inch drives, which are going to be your SATA disk, and they're going to be platter. So this is your slow storage. Okay, this is typically what a lot of like S3 is. They're just platter disk, and it's going slow. We also have 2.5, which is your SATA or SSDs. Typically, they don't have to be SSDs, but nowadays, lower space but faster. And then we move into the M.2 or PCI NVMe's, and these are kind of the 3 storage options that we kind of have nowadays. We also want to talk about the differentiate between local storage and network attached storage, which we're going to kind of go into. So we have kind of the 3 different storage mediums when we're thinking about a Homelab. Our slow disk, our kind of medium speed or SSDs, depending on price, and then NVMe's, which would be the fastest. I'm also going to just take a quick talk about RAID. So there's a couple different RAID types out there. There's software RAID and there is hardware RAID. Most of the kind of push in the industry has been to software RAID, and some of those like are ZFS and other kinds of software RAID platforms. Some common. So speaking of that, there's hardware RAID, which is just a card. You're going to plug in a bunch of hard drives, and the RAID controller itself is going to take care of everything. There's ZFS, which is part of a Oracle, I believe, and Solaris started the ZFS. It's a file system, and it actually does support doing RAID. There's BTRFS, another open source file system that can do RAID, even though the RAID 5 implementation has some issues. There's also Linux MD, so Linux RAID, software RAID, you can use that as well. These are some of the more common ones. I'll put a little diagram here of kind of how RAID works. If you want to learn more about RAID, I'm sure there's a ton of videos to kind of describe it. But in general, the biggest thing to take away is that when you're RAIDing, you can take a bunch of disks and you can combine them together to create or increase the space, right? What RAID can do as well is that it can either clone something, which is RAID 1. You could have RAID 0, which just is striping the data across all of the disk. If one fails, you lose all the data. And then we move into RAID 5, which you actually have a parity drive. So one parity drive, you have a minimum of 3 drives in a RAID 5. One is parity, and you can keep adding drives, but you can lose one drive and still keep the pool. And then we also moved into RAID 6, which actually has 2 parity drives. And then RAID 50 or RAID 60, where you actually start picking groups of RAID 5 pools and adding them together, right? The biggest thing to take away is that this allows you to put a bunch of disks together and try to make as much space as you can. All right. So we've got our platter disk, right? So this is an 18 terabyte drive. This is what they look like in a 3.5. It's low cost per terabyte. Okay. Then we have our SSDs, which are in the 2.5 form factor, and they are pretty fast as an SSD, but they're limited by the SATA interface that they have, which they share with the 18 terabyte drives over here. And then finally, we have our NVMEs, right? So this uses the PCI Express lane, and they are pretty much the fastest. All right. And talking about storage, we have local storage, right? So with all those disks, either whether it be a platter disk or a SSD disk or an NVMe, they could all live on your computer, right? So your laptop most likely has a hard drive. Nowadays, it's probably an SSD or an NVMe, and that's just a local drive, okay? And the benefits of that is that you have the fastest read and writes because you have the speed of whatever lane you're using. But it is single host, right? So that data just pretty much lives on the host. And there's no network limits because you're not sending that data over the network, okay? And it is also probably the cheapest to deploy local storage. So we also have network storage too, which is something you can consider. And this allows you to have storage that is shared over the network, right? And other computers can either access that over different file share protocols. And they have block and file. And the downside of this is that there's obviously some network limits that come involved with network storage, right? So depending on how fast your your network, your local LAN network is, will dictate how fast you can read and write files, right? And it increases some of the latency. It's really great for file storage. Not as good for block level storage, which is like, pretending to be the operating system or pretending to be a drive. Okay, so with that being said, let's talk about NASes, right? So the idea is that we could buy some disk and put it in our computer, and that's our local storage, or we could use it over a network. And to do that, we might want to build a NAS, right? So in that case, there's a couple options out there for building a NAS. I just wanted to kind of talk about them. First is TrueNAS. If you haven't played with this, it's come a long way in the ecosystem. It's a ZFS file system, so it has that software RAID I was talking about. You can actually virtualize VMs on TrueNAS. TrueNAS Scale supports Dockers and K3, which is actually Kubernetes, but just in general, think Docker containers. It also supports iSCSI, so you could actually have disk be assigned to a remote machine over the network, and the machine will think that the disk is local, right? Using the iSCSI protocol. It also supports the file sharing protocols, NFS, SMB, and yeah, so that's one good option. Another one too for home labbing that is pretty popular is Unraid. So Unraid is a kind of a different, interesting take. TrueNAS uses ZFS as the heart of its file system. Unraid kind of has its own, not necessarily file system, but way of rating that's not actually rating. The file system is actually XFS is what the file system of each drive is, but it does have a way of doing parity. It does have some benefits, which I'm not really going to get into all the details, but the biggest one is that you can just keep adding drives at will, and you don't have to worry about them being all the same size and some other stuff like that. Some other features of Unraid is that you can run virtual machines on them. You can make different pools that have SSD, for example, to run VMs, and a slow pool that would use something like Unraid. You can also run Docker containers on Unraid. And it does support NFS and SMB, but it doesn't support any block level storage protocols like iSCSI. Okay. That kind of plays into when you get into something like ESXi. We'll talk about virtualization, but in general, you can still use NFS if you want. All right. If you don't want to build, so I talked about TrueNAS and Unraid. Those are just two options. There's some other ones, but those are pretty popular. You can also buy. So Synology is another very popular solution. And if you do buy a NAS for storage, you're going to get hardware support, right? It is a little bit higher cost versus building, but obviously you're getting kind of this box that you just open up and you add some hard drives and you don't really have to, hopefully, do much configuration. Simplicity, right? And support, documentation, so on and so forth. I know that Synology, their operating system does support Docker and it does support VMs as well. But just something to note about this Synology, for example, is they typically don't have a ton of computing resources inside of them. So just be considerate of that. And they're more of just a storage device, right? So network storage that you could save a bunch of stuff to over the protocols. NFS, SMB are supported, iSCSI as well, supported on something like Synology. There's some other brands out there, QNAP and some other ones like that, that also have kind of like, by prosumer, I would say, to enterprise stuff you can buy off the shelf. Yeah. The other benefit of these is they're pretty low power platforms. When I talked about TrueNAS and Unraid, those are stuff that you're going to have to build on existing platform, or you can combine them together. All right. So we've talked about networking. We've talked about some storage, little storage concept about RAID. I talked about kind of the different drives you could buy and what the benefits are, speed, right, being one of them, and then space and cost. So let's talk about compute. So we have CPU, and right now, one of the more prominent or dominant architectures for our computing architecture is x86-64. I'm just going to refer to it as x86 for simplicity, but most of our systems now, operating systems, are 64-bit. We also have ARM, which is kind of the up-and-coming architecture. I say up-and-coming, it's been out for a long time, but it's starting to move more into your traditional computing space. Another part of compute, we have RAM. We've got our PCI lanes. I'm just going to talk about those. We also have GPUs. You can add a GPU. Every system pretty much needs one if you're going to actually have to interface with it with a monitor, but you could get more powerful GPUs to do things. We also have management. So a management can be as simple as a mouse and keyboard, or it could be more advanced. And then the form factor, right? So like, what is it? Is it a laptop? Is it a desktop? Is it a server that goes in the rack? What are all the differences, right? And the size, really. So we laptop, mini PC, and then a server. A server could be a mini PC, technically, or it could be something that's much bigger, takes up a lot more space. All right. So for x86, pretty much general purpose CPU. This is probably what most people are running right now for either their servers or their main operating system. Obviously, has the largest OS support, Windows being one of those. Intel and AMD primarily make x86 architecture processors. The x86 platform is typically higher power compared to something like ARM. It is probably the best for a server CPU or at any time going to do virtualization. Okay. It does have also the largest software support, even though a lot of what applications are being compiled for ARM, and it's not that. All right, so I'm going to talk about kind of some CPU performance. So I'm going to show you guys two things. Me and Corey sometimes go look at pass marks at different CPUs just to see how powerful they are. And I wanted to show this as kind of a comparison. This is the AMD Ryzen 9 5950X, okay? And what I've done is I went to this website called Passmark. You could just type in the CPU model and look up your Passmark number. You could do this on your computer right now. And this is kind of a general metric of, how fast this CPU and how much number crunching it can do, right? And the Ryzen 9 5950X is a pretty recent CPU. AMD actually just released their next line. But for this case, there is score of a 50 or 45,000, and there also is a single-threaded performance of 3,463. So this is kind of a general how much work it can do, right? Don't take this as like it will be fast at this. It's just a general idea, right? And then you can also see the typical TDP of 105 watts. So you can kind of get an idea of like how power hungry this thing is. Okay. I want to show you the next slide, which is the laptop version of that CPU. Okay, so this is the fastest Ryzen 9 CPU that you can buy in a laptop form factor, and it drops down to 25,000. Now, I just want you to be considerate when I think about when I talk about a laptop that would have this CPU is a monster. Okay, this thing is absolutely not very portable. Don't think Ultrabook. Think like gaming machine that it's 4 inches thick, pretty much. Okay. Now, the reason that is the truth is because of its typical TDP. While it's down at 45 watts, it can boost up to something like 100 and something watts. So they'll have a power brick to go along with it. It just gets bigger and bigger. But I just wanted you to know about the CPU mark. This is kind of when you do start your like Homelab journey or whatever, and you're looking at how fast is this. This is just a good, easy way to figure out what's the comparison. Okay. And also looking at that single threaded performance will tell you kind of how snappy something like Windows might be. All right. So that's x86, and let's talk about ARM real quick. So ARM has amazing performance per watt. Okay, so this is the other architecture, which actually a lot of us use all the time, and it's primarily used in our phones. Okay, so your iPhone, Android, all of that, they're running on ARM. The reason they use ARM is because it's low power, right? And you want a battery that lasts all day. Okay, but recently, Apple has actually taken that same ARM architecture and applied it to their general purpose computing or Mac OS, right? Not just their phone. And they did that with the Mac M1 and M2, which are actually very powerful processors in their own right. And with programs that are compiled for that architecture, you get some of the benefits of the power while also unleashing some of the performance that is actually possible with ARM once you give it more power, right? There's also ARM servers out there. We're not going to go into them, but there are ARM computing platforms. AWS has some, and there are ones that you can actually buy. They get a little expensive, but they can run as a general purpose server. Raspberry Pi is probably another great example of ARM. Okay, so the Raspberry Pi is an ARM-based platform. The Raspberry Pi 4 is actually pretty decently fast, and that is kind of a quick way if you want to play with ARM. Okay. ARM does have general limited Windows support. This was kind of a licensing deal, I believe, with ARM, but it started to open up. There is Windows for ARM, but in general, most people don't operate Windows out of ARM. So like I said, limited Windows support, to be determined in the future if Microsoft, for example, releases some laptop that's ARM-based. It's also not very good for virtualization because most likely you're trying to virtualize something that's not on the ARM platform. Ipso facto, it becomes a little bit more difficult, right? All right, let's talk about, so the CPUs that we're mainly talking about, x86, which is probably what you'll end up going with, and then we had ARM. All right, so for RAM, or for also with compute, we got CPU, we got RAM. And just quickly, there is a couple things to think about when you're looking at RAM, the size of the RAM. So you have DIMMs or SODIMMs. SODIMMs are usually in a laptop, DIMMs are in your desktop, right? So there's just different sizes and the memory chips that go on top of them. There's also embedded. So depending on if you have a laptop that is really small, they may just solder the RAM right on there and you can't upgrade. Okay. Another thing to consider is the speed. So DDR3 is an older standard. There's DDR2 as well. DDR4 is pretty modern. DDR5, I think, is the latest standard in memory for host operating system. Okay. There's also registered and ECC. That typically refers to server memory. I bring this up. So if you're looking at RAM and you've got this server, some servers only accept memory that is registered in ECC. ECC memory has error correction, and it's supposed to be better for overall, applications that need to make sure that RAM or memory has not been corrupted. All right. Also with compute, we have our PCI lanes. So we have CPU, we got RAM, we got some PCI lanes, depending on the motherboard, or if you get a laptop, you probably have PCI lanes, but you might not be able to add anything to it. But with that being said, there's a couple PCI different versions out there. This relates to how fast you can transfer down these PCI lanes. So they're up to version 6, but right now version 4 is pretty mainstream. Version 5 is just starting to move into regular production with consumer hardware from the Intel line. And they have different speeds and kind of different bandwidth. If you've ever looked at a motherboard, these are what the lanes look like. So you have a 1X, a 4X, an 8X, and 16. But what that means is the more lanes that are in there, the more throughput. You can see on this graph here that a 4.0 PCI Express with 16X lanes is 31 gigabytes per second, not bits, bytes. So lots of bandwidth. All right. So also, if you're dealing with compute, you could be adding a GPU, like this early production 4090 or whatever this thing is here. So why would you want to add a GPU for home labbing? Maybe doing password cracking. This is a good one for security standpoint. And also possibly crypto mining. Not a great time, but it's something that that's the reason the GPUs are really hard to get. ML and AI. So doing those, what do you call it? Different kinds of machine learning. All right. A lot of that uses GPUs to make that work. Obviously, having a GPU for your desktop and GUI, maybe usually also for playing games, but talking from a home lab perspective. So there are some downsides to adding a GPU to your system. Obviously, it does increase the cost. That could be expensive depending on how fast the GPU is. It can also definitely increase the power. Something like the new 4090, I think, takes like 600 watts or something. It's not. So obviously, that power increases the, when it is going all the time, that can increase the overall cost, right? It also increased the size of the case and not being able to fit that side there. So, all right. So we got CPU. We got RAM, talked about PCI lanes, right? So those would be for expansion cards too. GPUs, whether you're going to get a, more powerful GPU or not. And then also management. So anything that managing your compute could be something as simple as an external monitor or keyboard, or maybe something like IPMI, which is very common in server platforms. And this allows you to remotely manage the host without a keyboard and mouse over the network. Also, you could buy a KVM if you already have a monitor and keyboard and you put an extra computer as your server or home lab device next to your laptop, for example. You can just use a KVM to switch it when you do need that. But IPMI makes it a little bit easier to manage. There's also this other really cool device called the Pi KVM. So if you don't buy a motherboard that has IPMI and you don't want to use a traditional KVM, meaning that you don't want this device to be right next to your monitor, you can actually build a little device called the Pi KVM. I actually have one right here, just sitting here, and you can plug this in and you can use that to remotely access that device, right? Super useful and portable. You can use this for a lot of other use cases too. Good kind of home lab Swiss Army knife. All right. So we kind of talked about some of the concepts of compute, right? And we talked about storage and we've talked about networking. Let's talk about some devices in the compute, right? So home lab level 1, you could just use your laptop, okay? So what are some benefits? Well, low power, low CPU performance, though. It does have some thermal limits. And it obviously has some RAM limits because you can only upgrade so much. It's not always online, and there's really kind of no expansion, okay? But you do get to reuse your existing hardware, so you're reusing your laptop, you're just home labbing on it, right? It definitely has some limits, though. Okay. Next step, you could move to a mini PC, okay? So this is a little bit higher power, but you could use maybe a consumer CPU and moderate to high CPU usage. Or it could have a dedicated GPU if you're moving into like a desktop size, right? So like a smaller desktop. RAM limits around 128 in the consumer platforms. And it can remain online all the time, right? So you have your laptop, that's one option. Or you could build like a little small mini PC or a little desktop that you run all your stuff on. And it does offer some expansion depending on how big of a case you get. And you could reuse some of the hardware. The next step would be a server. So this probably is your highest power consumption. You could use an enterprise CPU and you could have multiple CPUs in a server. They could be high CPU performance, right? So you could have CPUs that are very fast. You could have dedicated GPUs in this kind of setup. Your RAM limits could be in the terabytes. So one system with terabytes of RAM. Obviously, a server can remain online all the time. You have something dedicated for this. You could get a lot of expansion depending on the size of the server, whether you put it in a case or you put it rack mount. And obviously, it's dedicated hardware, right? And in some of the server class items, you have redundant hardware, okay? All right, let's look at some computing options. This is where all the opinions start flying. But all right, the first one, buying a mini PC. Okay, so small footprint, low power. Obviously limited on RAM because it's kind of a mini PC, but you can put it wherever, right? And limited on expansion because it's small. But you can also easy to cluster. So this computer here I'm looking at is the Dell Optiplex 77 Micro. You can pick them up for about $300 or whatever on eBay, which I'll talk about getting where to get parts. But something like this is great as like an entry level Homelab server, right? Has x86, all the other fun stuff, right? It's nice and small, and you can buy a couple of them if you want. All right. I put a link in here for the tiny Homelab. I think I saw that one fly across the screen just a little while ago. But that's a little review about that. All right. So, or you next step after the mini computer would be building a desktop, right? You could use your existing hardware. If you stay in the consumer GPUs when you build this desktop, you can get a little cheaper. You can keep low noise if you use, large fans that keep quiet. There's lots of hardware choices when you're building your own desktop. It's gonna be kind of fun. You have the flexibility to expand to a new chassis or add new stuff later if you want. You can focus on the performance that you want and cheaper upgrade, right? So building a desktop is a great way. As far as CPUs, I do like the Ryzen 59 series or the 30 series is actually pretty fast. And I would avoid anything 12th gen or newer for the Intel if you're going to do virtualization, because Intel's newer CPUs use a big little architecture and it uses efficiency and performance cores. And Linux and other operating systems don't know the difference. And so you want to stay with the 12th gen or later. Finally, we could buy a pre-built server. So what you're looking at here is a Dell R730 and enterprise hardware, right? So new servers can be super costly. So just note that if you start looking at buying a new server on Dell, sticker shock is about to happen. But older hardware can be bought very cheap. The Dell R730 is a good option. Rack mount is probably the more affordable because that's what gets put onto eBay all the time because a lot of companies are recycling this gear. Desktop options of the server grade hardware are more limited, so they're more expensive. And performance can be lacking depending on what model you get, right? I would go with a Dell R730 or newer. And I only say that because performance. So you start getting into the Dell R710 or the Dell 610, the 10th gen. It's just not probably worth powering on. Okay. You could also build a server white box style, right? So you could do desktop rack mount. You could use a server CPU or a desktop CPU. Again, some of the benefits: low noise, lots of hardware choices, flexibility to change the case. I mean, you could pretty much do whatever you want, right? You could focus on your performance use case. Maybe you want more storage. Maybe you want more CPU, whatever it may be, right? And the upgrades can be cheaper because you only have to replace one part or maybe just the motherboard with the CPU, so on and so forth, right? You get a lot of options, okay? As far as CPU goes, Ryzen or Epics are good choices. The Epic second gen, I believe, is the probably the most cost affordable in the Epic line. You can also pick up the Ryzen 59s for pretty inexpensive and they're very fast. Awesome. Okay. Bonus, you could also build an ARM server if you want. And some of the benefits of that is Kubernetes, obviously super low power, low noise. DeskPi Super 6C, that's what you're looking at here, is a Raspberry Pi compute platform. It holds 6 Pi compute modules, but it's really good for something like you're going to be running bare metal. So Kubernetes is one good example. No VM support though. And right now, Pis are actually really hard to find. So yeah. All right. Where can you get some hardware? I kind of talked about different computing stuff. eBay is a good place. Reddit Homelab sales is an amazing place. I got the link here at the end. People sell gear on there for really inexpensive, really great deals. Facebook Market, if it's local, big stuff. And Craigslist, not as popular now as Facebook Market, but anything that's really big, like this server rack over here, I got on Craigslist for $100. I don't know, it's probably thousands new. But it's really big. It's hard to move, really hard to ship. So I got it for $100. All right, let's talk about virtualization and containers. Okay, so you bought some hardware, or maybe you're using your laptop. It doesn't matter. But hopefully you bought a little separate hardware so you can kind of play. So there's a couple different virtualization types that you can use to emulate virtual machines. So the first one is a type 1. So this is something like ESXi, right? or Proxmox, another really good alternative. You can pretty much run ESXi for free for the most part of the licensing. Proxmox is pretty much totally free. Both of them will allow you to run virtual machines, and they have a web interface to do that. You also have Hyper-V if you want to get into the Windows world, and you could run a Windows server like 2019 or 2022 or whatever, and you can run Hyper-V directly on that. I've never done a full deployment on Hyper-V, but you could definitely do it. Now, we also have our virtualization type 2s, or type 2 virtualization. And this is stuff that you're probably more accustomed to if you haven't set up one of these other platforms like VMware Workstation or VirtualBox, and anything that's running it on your host OS, right? So it's not a dedicated platform for just running machines, right? Last, as far as virtualization goes, and this is technically, it kind of moves into the other way to run applications, is containers. Not technically virtualization, but Docker and Kubernetes are kind of the two big platforms for container, right? So typically, if you bought that mini PC for like $300 or whatever, you could install Ubuntu directly onto it, or you could install a virtualization platform like Proxmox, and then you could run a bunch of virtual machines on it, right? You've got your firewall that we talked about. You got a little mini PC, you got your Homelab, right? You are ready to pretty much start emulating some fun stuff. All right. I do want to talk about one other thing, which is automation. So another thing to do when you have a Homelab is if you want to speed up deploying, you can use Ansible, and this can be used for host configuration. It can be used on Windows and Linux. You can use it to create baseline images. Also, Terraform is another great thing to use for deploying those virtual machines. You don't have to get into this at first, but eventually you might want to automate some of this stuff. And you can use Terraform to deploy your virtual machines. You could deploy to Proxmox or ESXi. You can also use Terraform to deploy to the cloud, which we'll touch on just a little. We also have Packer, which we can use for baseline images, and Windows and Linux is supported. And then Vagrant, if you're running stuff local, you can use that for testing out some of this. This should be for local VM deployments. And shameless plug, I actually have a class that talks about doing this for security, doing automation for security. So you can check that out. All right. Okay, so we built this lab. We got this hardware. What are we going to do with it? Here's some good ideas. All right. First, you could build an AD lab, maybe a detection lab. Okay, so looking for seeing if you can detect some kind of attack. You can use it for self-hosting. I have all kinds of self-hosted stuff. You can use it for IDS or IPS, logging using Elastic. And let's talk about that. So an AD lab, we could set up an Active Directory domain. That's a great way to get started in how Active Directory works. We can test out different Windows versions. We can also play with something like ADCS, which is the new hot attack surface, right? We could also work on our AD privilege escalation, right? Looking at different attack paths that are common. We could also test detonating our payloads inside of this Active Directory lab. We could also use it for EDR testing. We install EDR on one of our Windows 10 machines that go into a domain controller that we're virtualizing and see what happens, right? You could also set up detection lab. So I have a link here for detection lab itself, which is a lot of automated installation. You could do this locally with that hardware I just talked about, or you could deploy this to the cloud, which we'll talk about in a minute. But definitely check out Detection Lab, and this is a great way to run through detections, right? There's a little diagram of all the different stuff that gets set up. Detection Lab is very cool. Self-host it. All right, so something else you could do. You could set up your DNS like AdGuard. You could set that up. I have the links in here. You could set up your own password manager like Bitwarden, right? That's actually what I use as my password manager. It's awesome. You could set up your own file sharing, Nextcloud, anonymous email. So you could have, pretty much hide my email, but you could host it yourself. You could use set up Headscale, which is a Tailscale alternative for doing your own VPN deployment. You could set up a proxy IAM, which pronouncing that wrong, but anyways, it is a proxy IAM. What it does is it acts like Cloudflare Access, and you can host it yourself. You could do encrypted file drops, right? So this is Send is a Firefox project that was forked and allows you to do an end-to-end encrypted file share with people. Very cool. I have put the links for all of those in the slides here. And also right here, there is a self-hosted GitHub repo that has all of that stuff in it. You could also do IDS or IPS inside this network. You can set up Snort, maybe Circata. or Bro and Zeek. You can do network monitoring. You can do that on your firewall, depending if it supports it, or you could deploy these machines and get to kind of play around with it yourself. I have the links there for some of those network monitoring, IDS, IPS. You could also set up some security distributions like Commando VM, which is a Windows 10 distribution. You could set up a Kali box and use that for just running test. You could set up Parrot Linux, which is another attack box. You could set up Security Onion. This is a great VM that allows you to actually set up monitoring. Cuckoo Sandbox, so you can set up a Sandbox VM, and this is going to all be on the same host, right? There's another project called Teapot Honeypot, more recent Honeypot deployment. You could set up to see what's going on. You could set it up from a perimeter perspective or just internally to see if actually someone's on your network, right? You could also do some logging, right? So Elastic EDR is another really great product to set up with setting up Elasticsearch. You can learn how Elastic works. You could be educated on how to deploy these things. So, that could definitely help your job depending on what you're doing. You could set up logging to your own systems into Elastic, setting up Kibana for web searches, setting up Logstash to even stash your own logs. You can set that all up and monitor it all, and FileBeat to do that. There's another project out there if you want to kind of do a one-click deployment called HELK, and this is more of a threat hunting platform, and it kind of does all this setup for you. I've included the link in here and how to do that deployment. If you have one of these machines that in your home lab, guess what? You could do this too. This has a lot of different advanced features in it. But I mean, again, this all allows you to play in that platform, right? All right. So you could host it at home. You could also do it in the cloud, right? And why would you want to do it in the cloud? Here are some reasons. Maybe you don't want to buy any hardware, right? You can scale quickly in the cloud. It's pretty fast to set up if you've ever played with the cloud. But it's more expensive long term, okay? It also does have limited Windows support inside the cloud, unless you get into Azure. And more control, or it's more work to control your costs in the cloud. So these are kind of some of like the whys and the, kind of the downsides, right? But there's a couple different cloud providers out there: AWS, Microsoft Azure, DigitalOcean, Vultr, Hetzner is another one that I've used. There's other ones out there. I just thought I would throw a list out. But as far as building a cloud lab, like maybe trying out one of these VMs inside of a cloud, when should I do that? Well, you should do this if whatever you're trying to do requires a bunch of uptime, because the cloud's going to provide that uptime for you. That's what you're paying for. Or maybe you need redundancy, like you don't want power to go out, so on and so forth, right? You need it to be online. Or your use case is really short. I need to test something out for like a day. Like buying a whole nother computer seems kind of superfluous, right? You need fast upload. Maybe you just don't have fast internet at your house, and this particular thing that you want to do requires a bunch of upload. You need a public IP. Most of the time, you only get one public IP from your ISP. So that's another reason to use the cloud. And a quick deployment, right? Maybe you don't have Proxmox set up and you don't have all this stuff. So just faster to do it, right? And automated deployments, right? That's whenever you have automated deployments, that really helps the whole cloud, right? Cloud is very useful for that. Or maybe you want to use it for backups. Backups is another great place for the cloud, because guess what? It's not at your house. So if something happens, you actually have a real backup. All right. When should you avoid the cloud? Well, if you have lots of Windows stuff, you probably should avoid. It gets really costly. And actually, the only place you technically are allowed to run Windows 10 is Azure. You can run Windows Server on AWS. So if you have high performance requirements, you're going to do like GPU cracking, avoid the cloud. You have no uptime requirements. Like it doesn't matter if this thing goes offline, then why are you putting it in the cloud? You have no automation. You should probably avoid it, because that is going to create costs that you're not going to be able to get back. Or you have high storage requirement. So you need to store a lot of stuff in the space in the cloud. So cloud on the cheap. One recommendation, if you do want to use the cloud, is I use Hetzner. There's a lot of other cloud providers, and they all actually are kind of similar. But the only reason I'm going to bring up Hetzner is the price here is crazy cheap. You can get like 2 CPUs, 4 gigs of RAM, 40 gigs of space for like $5 a month, or €5, about $5. So there are other cloud providers, and maybe you have credits at those. Use those if you need, but just take those other things into consideration when you start getting onto the cloud. All right. As far as the community goes, we got the BHIS Discord that you're on right now. This is a great place to ask Homelab questions. We also have the Homelab Reddit and the Homelab Discord. These are another great places to find discounts on gear and to ask questions about what you should or shouldn't do. People love answering that all the time. And then let's do a quick little recap. So decide what you want to learn and what you want to do, right? That's the first thing. Next, buy the right hardware. After you've kind of decided, hey, I want to go down this route, get the hardware that's hopefully going to get you there. Try to provision a little bit more so that you don't just kind of get there and you're like, crap, now I got to upgrade. But just think about that. Use automation when you can. So Terraform, Ansible, those things can either save you money when you're doing the cloud, or they can just actually help your own deployment at home, and you get to learn how they work. Know when to use the cloud. Okay. Sometimes the cloud makes a lot of sense. Other times it's just kind of a waste of money, right? All the benefits you're not benefiting, and you probably should just run it at home. There are more open source software to play around with than you have time. Okay. So just know that, and that's fine. It's fine. But having a home lab and being able to run those, that makes it fun. All right. And join the community, right? Questions. Rapid fire right to the end. Become one of us.
Yeah, you're going to need to stop that slide.
All right, I'll stop this slide.
Hey, good job, Ralph. Look at all that home lab. All right, so the link to the slides, let's get that available. John, I don't think your audio is working yet. There you go. Oh, you're all good now. So we had some volunteers or fellow community members that were just killing it answering questions inside Zoom and on Discord. So I want to say thank you to those of you that were answering questions and helping your fellow attendees, because that was awesome. Thank you for doing that.
Oh, what is my setup? All right, this will be fun. So top down, right? And I don't know how much you can see here. So I have a Unify 10 gig switch. I have a Unify UDM Pro, which is a firewall router device. I have a 24 port Unify switch. And then going down, I have a Proxmox system running Ryzen. I have a 4U server that runs just a gaming computer. And then below that, I actually have a file server.
Can't hear you, Ralph.
Oh, sorry. I also have a file server down there, which I don't know if you can see. But anyways, there's a bunch of fans in the front of it, and it has, I don't know, it's like 200 or 300 terabytes of storage in it.
And what are you doing there?
Anything I want.
That's nice. All right. I'll see a few questions here. Have you used Microsoft's pre-built labs before? They only deploy on Hyper-V, but do have basically a full ENV. I don't know what that means.
So I have not used Microsoft pre-built lab. I have done a couple different deployments to Azure. Again, I get a little wary on some of those depending on how much they're going to cost, right? The more full featured it is, the more expensive it can get. And so like I kind of said in my slides, is that if there's automation involved, it's definitely something you want to take a look at because you can get rid of it really quick, right? You're not like stuck with it. But if it's something like you're manually building, then, you know, I would avoid that process. I know a lot of it does include automation, so that makes it better. So.
All right. Last question before we wrap for today is, how do you estimate the cost of power usage for all the equipment that you have?
Oh, okay. Yeah, that's a great question. So the general gist is most computers use about, like a desktop computer uses about 100 watts, right? 120 depending on the server. Some smaller computers use less than that, looking about 50 to 60. So I would say a great way to budget power per computer, I would say 100 watts.
And John, you're on mute or something.
Double muted. You can also go to hardware stores and you can actually get devices that'll record how much power is going through as well.
Yes, it's called a wattometer. And you can plug one of those in and get a good idea. Depending on what you have, it could use a lot less than you think. But I think a general gist, if you want to like, hey, how much do you think this thing's going to cost power wise? I'd say 100 watts. And then if it seems crazy, then get a wattometer.
The other thing you can do is just keep adding things to the circuit until it blows. Once you've tripped that circuit,
then you know it's 15 or 20 amp. That's an easy way. It's also an easy way to blow up your power bill.
Yeah.
All right, everybody. It is 2:00, which means it's the end of the webcast today. I'm sure you have lots of questions, and we'll take those questions and see if we need to write a blog or do a future webcast with it. So thank you so much for being and participating with that.